So, good morning, everybody. So, in this lecture, we will discuss some of the problems related to the triangular notch, that is V notch. In the yesterday's lecture, we discussed how to determine the discharge flowing over a triangular notch or V notch. That we found, and we have derived the equation also for the discharge. Q actual is equal to CD into 8 by 15 root 2g tan theta by 2 into h to the power of 5 by 2. One more interesting thing also which we found yesterday is, in case of a triangular notch, if 1% error is committed in measurement of head, the corresponding error in discharge is 2.5%. That's what also which we have shown. In the previous lectures, for rectangular notch also we did the same exercise, in the sense that for a rectangular notch, if 1% error is committed in measurement of head, the corresponding error in discharge is 1.5%. Whereas in triangular notch, if 1% error is committed in measurement of head, the corresponding error will be 2.5%. These are all excellent quiz questions. Please note them again. And now I will straight away take you to the problems. The equation for discharge in the case of a triangular notch, which is also called as V notch, is Q is equal to CD into 8 by 15 root 2g and theta by 2 into h to the power of 5 by 2. Another important question I mentioned, if 1% error is committed while you are taking readings in measurement of head, the corresponding error in discharge is 5 by 2%, that is 2.5%. Now let me go into the first problem. Water flows over a rectangular weir 1 meter wide at a depth of 150 mm. Afterwards, passes through a triangular triangular right angle means theta is 90 weir. Take CD for rectangular weir and we triangular weir as 0.62 and 0.59. Find the depth over triangular weir. So now there are two things here. One is rectangular, one is triangular. Water is flowing through first flow over rectangular and then over triangular. First rectangular I will take, it is 1 meter wide, L is equal to 1 meter. Depth H is equal to 150 mm, 0.15 meters. And then CD is equal to 0.62. Then for this right angled, that means theta is equal to 90 degrees. And then what is the other thing? CD is equal to 0.59. What is the question? What is H here? So given this is given and this is what asked. So now I will do with the given thing, I will take it. Q is equal to 2 by 3 CD L root 2G H to the power of 3 by 2. If I take this, then 2 by 3 CD is 0.62, L is 1 into root of 2 into 9.81 into 0.15 whole to the power of 3 by 2. So if you calculate that, you are going to get 0.10, basically 63 meter cube per second. Right? So now the same discharge is flowing over triangular notch. So triangular notch discharge is also equal to how much? 0.1063 meter cube per second. Right? This is the same because the same is flowing. Now if I take it for triangular notch, Q is equal to CD 8 by 15 root 2G tan theta by 2 H to the power of 5 by 2. Q is already known, 1063. CD is 0.59 into 8 by 15 into root 2G is 2 into 9.81. Tan theta by 2 means tan 90 degrees, 45 degrees, 1 into H to the power of 5 by 2. So what is H? So that H is equal to, you calculate, H is equal to 0.3572 meter. So it's a prominent question given in SEM and exam very recently. This question. Then next I will take one more question, actually the second question here. A right angled V notch is used for measuring a discharge of 30 liters per second. An error of 1.5 mm was made while measuring head over the notch. Calculate percentage error, the percentage error in discharge. CD is equal to 0.62. So theta is equal to 90 degrees. Q is equal to 30 liters means 30 into 10 to the power of minus 3 meter cube per second. Then DH is equal to how much? has mentioned 1.5. So 1.5 mm. So 1.5 into 10 to the power of minus 3 meters. Then CD is equal to 0.62. So if I take it actually, first thing is for a V notch, what is H? This is the first question. Then for that Q is equal to CD 8 by 15 root 2G tan theta by 2 H to the power of 5 by 2. Q is equal to 30 into 10 to the power of minus 3. CD is 0.62, 8 by 15 root 2 into 9.81 into tan theta by 2 means actually into 1 into h to the power of 5 by 2. Therefore, h is equal to, if I calculate first that, then automatically h is equal to 0.211 meters. And we know that again dq by q is equal to 5 by 2 into dh by h. This is for V notch. So what is dq by q is equal to, that means what they asked actually, the question itself is what is the percentage error in discharge. So therefore dq by q is equal to 5 by 2 into dh is how much we have got already. We have given you 1.5 into 10 to the power of minus 3 dh. H is equal to 0.211. So if you calculate this, you are going to get point basically 0.1776, or it is nothing but 1.77%. Very important. So these are the two questions. And once more also I mentioned actually at one place while talking about the trapezoidal notch, what is suppletive wear? Suppletive wear discharge is equal to same as suppressed rectangular notch or wear. So Q is equal to 2 by 3 L root 2G H to the power of 3 by 2. So any suppletive wear problem you can solve it like this. The problem is find the discharge over a suppletive wear of length 2 meters when the head over the wear, when the head over the wear is 1 meter, CD is equal to 0.62. So L is equal to what we have given, it is L is equal to 2 meters, right? Then other one, what is the other thing he has given? H is equal to 1 meter, CD is equal to 0.62. Therefore, Q is equal to CD 2 by 3 L root 2G H to the power of 3 by 2. Substitute in this, QCD is equal to 0.62 into 2 by 3 into L is 2 into root 2G 2 into 9.81 into H is 1 to the power of 3 by 2. Therefore, Q is equal to 3.661 meter cube per second. This is one of the problems again. So that's all the problems basically in the case of a triangular notch. Here I will stop basically this particular topic. So with this, unit with this unit 2 is over. So kindly in the unit 2 basically we have one is fluid kinematics, The other one is fluid dynamics. In the fluid kinematics, first continuity equation, types of flow, velocity, potential, stream function, flow net. So all revolves around that. Then second here, Euler's equation, Bernoulli's equation. From the Bernoulli's equation to applications, Venturi meter, orifice meter, pitot tube, and then basically once the pitot tube is over, impulse momentum principle. Pipe bend problems, the last is notches, rectangular, triangular, trapezoid. So these are the things. Here, the recent question that was given is derive the Bernoulli's equation. Along a streamline. In the regular class, what I have done is I have done for basically for three-dimensional flow, which is in Cartesian coordinates. But this also you prepare. This is recent sum and exam they have given. So with this, we'll close this topic actually and go into the next unit in our next class.
Like, share, and subscribe. Hit the bell icon for more updates.